हेलो बच्चों, गुड इवनिंग। हाउ आर यू? A very good evening to student of JNV Ramnagar and student of JNV Ravli, which is not with us. So sorry for the disturbance. Sorry for the late, for being late. Actually, there is a problem. There is a technical issue in my PC. So I'm rectifying that to present this lecture in front of you. So I welcome you all in this lecture. This is the question discussion on fluid mechanics. So here our today's topic is fluid mechanics, and we will see the question from Archimedes principle, the pressure difference. Okay, so several question we are going to see. Although these question include the question from JEE mains also. Okay, and NEET, as you can see on your screen. So today's agenda is to cover the few of the topics of fluid mechanics, and we will get this series with 3 lectures so that we can cover all the topics with the PYQs, respective PYQs. So are you ready for this? A student of JNV Ramnagar is here. How are you guys? Okay, so we will wait for 1 minute. And meanwhile, you will see this question. This is question number 1 on your screen. And it is the latest question that has been asked in JEE in 2023. Okay. Okay, you are fine. I am also fine. So you can see these are glitches that is coming in my laptop. So this is the question in front of your screen. Uh, in this, the matching type of question is given to you. There are two lists. So in this, two lists are given to you, and you have to identify the unit of this. Look how simple this question is. Okay. So try to attempt this question. So first option that we have here, option number A is surface tension. Okay. So surface tension we have here. So student is saying that option B is true. Okay. So let we see which option is correct. So here surface tension is nothing but we have seen in the yesterday class. Surface tension is force per unit length. Force Newton, length meter. Newton is nothing but it is the force, and force is given by mass into acceleration. Mass is kilogram, acceleration is meter per second square. So it must be has a unit of kilogram, meter, and this second square will come in denominator. And in denominator already we have meter. So it is meter second square. Meter and meter will cancel out. So it will become kilogram per second square. Okay. So for option A, where is the kilogram per second square? Here. Option fourth is the correct one for A. So A is fourth. Okay. So we are only restricted to these two options. B is third in both of them, which means B obviously has third answer. These types of question include lots of logical reasoning. If you go according to your logic, then you do not need to apply the formula and concept and all. Okay. So B should have option as 3, then you have to only correct C and D. Okay. And in which also you just have to find one of them. If you find C as 1, so definitely D will be 2, because in this option D cannot be 1. Okay. So if I talk about C or D, D is impulse. Instead of viscosity, impulse is easy for us. Impulse is nothing but change of momentum. So it is mass into velocity. Mass is kilogram, velocity is meter per second. So it is kilogram meter per second. So C should have kilogram meter per second is first option. Kilogram meter minus 1 means kilogram per meter per second. So this cannot be the answer because here meter is given in minus 1, which means kilogram per meter second. So this cannot be the answer. Option second can be the answer, kilogram meter per second. So C has answer 2. So definitely D will be 1. So option B is correct. Okay. This type of logical reasoning in these questions will not only going to save your time, they will give you more analogical view. Okay. So next time you hit with these types of question, try to apply the logical reasoning between the answers. Okay. Now, question number 2. A hydraulic automobile lift is designed to lift vehicles of mass 5000 kg. The area of cross sectional of the cylinder carrying the load is 250 centimeters square. The maximum pressure the smaller piston would have to bear is. So before I discuss this question, I will tell you the concept behind it so that it would be easier for you to understand. Na? So for the concept part, question is based on the Pascal's law. And what is Pascal's law? Pascal's law will says that the any disturbance in a static fluid, any disturbance in static fluid, disturbance mean any change of pressure in an incompressible fluid will reach out to each and every point of that fluid without any loss. So we are going to apply this. This is the hydraulic lift. Okay. These are the pistons. We can push this piston up and down. Okay. So this smaller limb, smaller cross-section area, smaller force is there. So let's say force F1 is applied here and the area of cross-section is A1. Force applied here is F2 and area of cross-section is A2. Okay. And there is a incompressible fluid which is filled inside this hydraulic machine. So what we are going to do, when we push this piston down, it will change or disturb the system, or basically it is changing the pressure of the system by applying force on it. So this change or disturbance will go to this side without any loss. This is the Pascal's law. Okay. So we can say that force here is F1 equals to pressure P1 into A1. Okay. And on this side, you can say that force F2 is equals to P2 into A2. Okay. Now, F1 here is P1 here is F1 over A1 and P2 is equals to F2 over A2. Now, Pascal's law says that this P1 should be equals to P2. So when you equalize that, F1 over A1, F2 over A2, and you rearrange this system, it will become F1 over F2 is equals to A1 over A2. Okay. So this is the concept we are going to apply in this question. Now look, let's have a look of this question. A hydraulic automobile lift is designed to lift vehicle of mass 5000 kilogram. So the area of cross section of the cylinder carrying the load is 250 centimeters square. Now the maximum pressure the smaller piston would have to bear is. Try to solve this question. Everything is given in the question. No need to worry about the data. Okay. So option D you are seeing. Let's have a look if you are saying correct or not. And I just appreciate your work if you are solving questions. It's very good. So this is the lift we have. Let's say this is the cross-sectional area A, A2, and this is A1. Here we have applied a force F1. Here we get a force F2. Here the pressure is P1. Here the pressure is P2. Now, we have just seen that F1 over F2 is equals to A1 over A2. Okay. Now, it can lift the vehicle of mass 5000 kg, which means it is the maximum weight it can lift. Okay. And the question has been asked that the maximum pressure of the smaller piston. So to apply the maximum pressure, we should lift the maximum weight. So we will put this F1 as the weight, because if we put the 5000 kg here, it will apply a load on this side. So to lift this heavy load, we have to apply a force here. Got it? So from this, we can say F1. F1 is nothing but F1 we do not know, divided by F2. F2 is the weight, which is mg, is equals to A1. We don't not know, or A2 is 250 centimeters square minus 4. Okay. So here you can say that F1 over A1 is equals to mg over 250 10 raised to the power minus 4. This F1 over A1 is nothing but the pressure of this side, which obviously be equal to the pressure of this side. So P1 here, mg, m is has a value of 5000 into 10 divided by 250, 10 raised to the power minus 4. You get it cancel out. So it will become 200. It will become 2000. So P1 will become 2 into 10 raised to the power 6 Pascal. So this is the maximum pressure that a piston would have to bear. Okay. So you are correct. Very correct. Absolutely correct. Option D is the correct option. Okay. Now let's move on to the next question. Yeah. A pressure pump has a horizontal tube of cross-sectional area 10 centimeters square for the outflow of water at a speed of 20 meter per second. Okay. The force exerted on the vertical wall just in front of the tube, which stop water horizontally flowing out of the tube is. Okay. So in this case, we have a pump, okay, which supplies the water in a horizontal tube. This is the tube we have cross-sectional area 10 centimeters square. Okay. And the water flows with a speed of 20 meter per second. Okay. So there is a stopper. Here we have a stopper. We put this down when we do not need water, and we put this up when we need water. So when we apply the stopper on this cross section, the water will apply a force on it. So that value of force which is exerted on this stopper or the vertical wall has to be asked. So try to solve this question. You got it? What has been asked in the question? There is a motor which supplies water with a speed of 20 meters per second through a cross-sectional area 10 centimeters square. We had a stopper here. So when we do not need water, we apply this stopper. So in that case, what should be the force that is applied by the pump or water? Because pump is basically supplying the water. So that force is actually exerted by water itself. So try to solve this question. You have 2 minutes. 2 minutes to solve this question. And solve this question by your own. Do not seek help. Okay. Okay. When you solve your question by your own, na, You will feel more confident. होता है ना ऐसा? And this is also from she Mains 2023. Okay, try to solve it. And whenever I will say you that try to solve this question, and you are trying to solving that question. So in the chat box, please write T, only T, so that I can understand that you are trying to solving this. Okay, so I will give you some time. And if you are not trying, so write NT. Okay, don't worry that sir, what would sir think about that? Do not worry about that. Okay, so are you solving this? Again D. Okay, so you are saying D is the correct option, huh? So let me see. Firstly, we will see the concept of it. So the reading is visible to you on this black screen. I think it will be visible. So this is the pipe that we have, or let me change the color for you. And in this, the water is being flown at a rate of 20 meter per second. Or let's say in general case, we are assuming water is flowing with a speed of V. Okay, V meter per second. Now, the pump, this speed is gained because of the pump. So when we apply a stopper here, okay, so liquid will exert a force on this stopper. This is F. Okay. How do we measure force? The force exerted is equals to change in momentum per the rate of change of momentum. I will write it here. Rate of change. Rate of change of momentum or change in momentum. Okay. Because when water hit this surface, it has some momentum, and when it strikes, the momentum will be gone because velocity will become zero. So there is a change in momentum. So we are going to do that. What is the change of momentum? So if I write the formula for momentum, so P is equals to m into V. Okay, V is the velocity, m is the mass. Now we will consider that mass. I have told you in fluid mechanics, we do not write m as it is. We will write it is in terms of density volume. So mass is nothing but density of the fluid into volume multiply by. Now this volume, if you will consider this for time t, so in time t, this fluid which is at the cross section will cover a distance v into t, v into t. So this much volume of water enters in the tube in time t. Okay, and it has length as v into t, and area of cross section is nothing but A. So this much of volume enters in the tube in time t. That is nothing but the volume flow rate. So I would like to write volume in terms of this. So volume will become what? Area into length, and length here is velocity into time. I am representing the speed or velocity with small v, and volume with capital V. Put the value of capital V here. So rho into area into V into T into V, this wala V, small v. So it will become rho A V square into T. Now, this is the momentum. We know that force is equals to dP by dt. So if you integrate it, differentiate it with respect to time. So it will become rho A V square. So remember this formula. The force exerted by a pump on a vertical wall, or you can also use this formula in the case when it is said that a liquid jet, a jet of liquid, a jet of liquid apply force on a vertical wall. So in the both of the case, you can use this formula. Okay. So note this, whatever I have taught you, note this down. Now, in this, now you will directly apply the formula. So force exerted here is rho A V square. Rho is 1000 for water. A is A is nothing but area of cross section. Convert it into meter. So it will become 10 into 10 raised to the power minus 4 multiply by velocity square. So 20 square will become 400. So it will become 1000 10 into 10 raised to the power minus 4 into 400. This will cancel out this. So it will become 400 Newton. And you guys are absolutely correct. Very good. Definitely very good. So I appreciate you clapping for you. You have did it correct. Now move on to the next question. Now this question you have to do. And here the acceleration is g and this angle is 30 degree and you have to calculate this angle. Okay. So try to solve this question. Just a second, just a second. Try to solve this question. A container of liquid is accelerated along a direction shown in figure. So it is the acceleration given in this direction, the line. Find the angle made by the liquid surface as shown. So this angle you have to calculate, or you can also try to calculate this angle, theta. Okay. So try to calculate it. I am giving you once 2 minutes to solve this question. Okay. I have told you in the regular classes the concept of accelerated vessel. So try to solve this question. Okay. So let me tell you the story behind this question. This is the vessel. Okay. And if it is accelerating upward, firstly. So I have told you the pressure difference between A and B, it is PA and PB. The pressure difference PA minus PB will be in the case when there is no acceleration. So you are saying that angle is 30. So in the case when there is, let me check. In the case when there is a pressure difference PA minus PB and there is no acceleration, the fluid is static. So it will be simple rho G H, you know. But when PA minus PB is equals to rho G H, but when there is an acceleration in upward direction, so what will happen? The pressure difference you will have as Z plus A into H. This is in case of vertical acceleration. But when there is an horizontal acceleration, this is A, this is B, and this is accelerating in this direction. So here, in this case, the pressure difference will be PA minus PB as rho into length of the vessel into acceleration. Okay, this. So in case when the vessel is accelerating in a random direction, and this angle is, let's say, theta. It is A. This component will become A cos theta, or you can say it is AX, and this component will become AY. Okay. So if you calculate the angle, what the surface will make, and if this angle is theta, let's say, so tan theta here would be AX upon, there is a downward direction, and these are in opposite direction, AY and G. So it will be AY plus G. Okay. But when it is accelerating in this direction, so this will become AY minus G. Got it? So this is the silly concept behind it. Small concept. So it is tan theta in this case. Okay. So we will try this question now. So this A G cos theta. So A here is G. So AX would become A cos 30 and AY would become A sin 30. So A cos 30 is equals to A is nothing but G cos 30 root 3 by. So it is G root 3 by 2 meter per second square. And it is A G into A is equals to Z. Sin 30 is 1 by 2. So it is G by 2 meter per second square. Now, tan theta according to this scenario. Now, gravity and this given acceleration is opposite direction. This is AY and this is V. So we know that it is AX upon AY plus G. Okay. So AX is nothing but, what is the value of AX? It is G root 3 by 2. And AY G by 2 plus G. So root 3G by 2 divided by 3G by 2. G by 2, G by 2 will cancel out. It will become root 3 by 3. It is equals to 1 by root 3. So tan theta equals to 1 by root 3. Okay. So theta here, theta is equals to 1 by root 3 is a value of tan 30. So theta would be 30 degree. Okay. Got it? Now, if this angle has been asked, what you can do? If this angle has been asked, so calculate this angle and divide it by, sorry, subtract it from 90. Because if this is theta, this is 90 degree. So this definitely would become 90 minus theta. 90 minus 30 is equals to 60 degree. Okay. Now try to calculate the answer if the direction of acceleration is in this direction and this angle, this time, this angle is given to you as 60 degree. Now I'm giving you 1 minute to solve this question because now you got the formula. Just try to apply it. Calculate the value. Calculate the value. This time AX and AY would also change. Okay. So this time acceleration is in downward direction, making an angle 60 degree with the horizontal. So we have AX as A cos 60, which is G by 2. So cos 60 is 1 by 2. AY we have in downward direction now, AY, which is A sin 60, and it is nothing but root 3G by, because sin 60 we have as root 3 by 2. Now tan theta, how to calculate? Component in horizontal direction divided by component in vertical direction. But you have to take the A effective in the vertical direction. So A effective would be, because they are in same direction, so relative acceleration would be AY minus G. Okay, got it? And you have to take the mod of it because maybe this quantity came out as negative. Okay, so you have to take the mod of it. So AX here is G by 2. AY here is root 3 by 2 into G minus G. So G by 2 divided by root 3 minus 1 by 2 into G. You can cancel out this G by 2 with G by 2. And this tan theta here is equals to 1 upon root 3 minus 1. You can also make it more clear. So you have to multiply with root 3 plus 1 in denominator and numerator. So it will become root 3 plus 1 divided by root 3 minus 1 into root 3 plus 1 will become square of root 3 minus 1 square. So tan theta you would have as root 3 plus 1 divided by, okay. So this is the value of angle. So theta you can also say that it is tan inverse root 3 plus 1 divided by 2. Okay, got it? Clear with this question? With the change of this question? Clear है? Write yes or no. So you are saying that this is incorrect. Huh? Tan theta is ax upon ay minus g. Okay. So ay minus g is the effective acceleration. And why we are taking it? Because now container is also accelerating in downward direction. Okay. Okay. Acha. LCM you are. Got it. Instead of 1, it will be 2. Got it. So this will become root 3 minus 2. So root 3 minus 2, it will become 4. It will become root 3 plus 2. And definitely 2 square. Here will be 2 square. So 2 square will become 4. And it will become 3. And I have told you that you have to take the mod of it. So it will become mod minus 1. Got it? Now I'm doing correct? Yeah. And very good. You are paying attention to this. It means. So tan theta is root 3 plus 1. So here you will have root 3 plus 2. Root 3 plus 2. So tan inverse root 3 plus 2. Now it is correct, na? Have you got the same? Okay. So there is another question from the same series that can be asked. So the container is same and you have to find the angle also. But the question says such that the value of acceleration now. Acceleration is given you as t square meter per second square. Okay. And we have to find theta at t is equals to 2 second. Got it? Now for t is equals to 2, you need to put the value of time t is equals to 2 in this expression. Then you will have the value of acceleration at that time. Then you resolve it into two component. The angle is same, 30 here. Okay. Try to find out the answer. Just give me 10 seconds. Okay. So let's just start solving this. So at t is equals to 2 seconds, the value of acceleration will become 2 square, which is 4 meter per second square. Now ax would be 4 cos 30, which is 4 cos 30 would be root 3 by 2. So it is 4 root 3 by meter per second square. Ay would be 4 sin 30. So it will be 4 into 1 by 2. You can say it 4 by 2 meter per second square. Now tan theta is nothing but ax over ay plus g, because ay and g are in the opposite direction. Okay. So ax would be 4 cos 30, which is 4 root 3 by 2 divided by ay plus g. Ay is 4 by 2 plus g is 10. So you can say this 4 by 2 is 2 plus 10 will become 12. 4 root 3 divided by 12 into 2. 2 to the 4, 4 6 12. It is root 3 by 6. So you can say it 1 upon 2 into root 3. So this is the value of tan theta. Tan theta here would be 1 upon 2 root 3, or theta is equals to tan inverse 1 upon 2 root 3. Okay. Any problem in this? Have you got the same answer? Yes or no? Okay. Now, this question, try to solve this. This is from the Archimedes principle. A solid body is floating in water, has 1 by 5th of its volume immersed in it. 1 by 5th of the volume of that solid body is inside. What fraction of its volume will be immersed if it floats in a liquid of specific gravity? 1 by. Okay. So we have to find it out. So try to solve this. I'm giving you 2 minutes to solve this question. Okay. करो solve. Try to solve it. Apply the concept. The concept that we're going to use in this is the volume of solid inside the liquid, let's say fluid, equals to the volume of displaced water. Okay, because whenever the solid, any material you drop it into the liquid, it will displace the same volume of water. Okay, so this is the concept of this question. We are going to use this. Now, it's V by 6 you are saying. Let's have a look. So we know that for floating, the weight should be equals to the upthrust. इसमें तो किसी को कोई डाउट नहीं. फ्लोटिंग की कंडीशन में लेट्स से दिस इज द कंटेनर. थोड़ा टिल्ट हो गया कंटेनर, बट यू कैन अज्यूम इट अ सीधा कंटेनर. So this is the block we have. So in the condition of floating, the buoyant force that is applied on this, the buoyant force is nothing but the upthrust. Okay. This equalizes the weight of this. Got it? Now weight we can write sigma. Sigma is the density of this solid. Or let me remove the confusion. Density of solid into volume of solid into gravity. Or start from the very basic. Weight is mg, m rho v, density into volume, density of solid, volume of solid into gravity is equals to upthrust, which is the buoyant force. Buoyant force depend on density of liquid, volume immersed, volume immersed into gravity. So G and G would cancel out. So density of solid divided by density of liquid, which we have used water. This is water. So we will take density of water is equals to volume immersed divided by volume of solid. Now in the question it is given when it is being dropped in the water, it has 1 by 5th of its volume immersed in it, which means V by 5 is the volume immersed. It is Vs by 5, volume of solid. So we can write it as V of solid by 5 divided by V of solid. So rho of solid divided by rho of liquid, any water, is equals to 1 by 5. This is equation number 1. So when we drop this solid in another liquid, which has a specific gravity 1.2, the specific gravity of this liquid is 1.2. The specific gravity is nothing but rho of liquid divided by rho of water. Okay. Now, we will assume that 1 by nth of the volume is immersed in the liquid. Okay. Like total volume is V. 1 by nth of it is immersed in this particular liquid. So we are going to apply the same. Rho of solid divided by rho of liquid. Now we do not know that this liquid is water or not. The specific gravity is 1.2, so definitely it will not be a water. So rho of solid is equals to volume immersed. So we have assumed it Vs by n. divided by volume of solid. Now, again, this VS will cancel out. Rho of solid divided by rho of liquid is equals to 1 by n. Now, rho of liquid, you can replace it by 1.2 into rho of water. I will do it in the next page. Rho of solid divided by rho of liquid is equals to 1 by n. Now, it is given that specific gravity of that liquid is 1.2. So, it is nothing but rho of liquid with respect to water is 1.2. So, rho L we can replace 1.2 into rho of water. Rho of solid divided by rho of water into 1.2 is equals to 1 by n. Now, rho of solid divided by rho of water is nothing but 1 by 5. So it is 1 by 5 into 1.2 is equals to 1 by n. 12, you can assume it 12 5s are 60 and there is a point on one place. So it will be 6.0. So 1 by n will be 1 by 6. So n is 6, which means V by sixth of the volume is immersed. So you are absolutely correct. You are a very intelligent student of JNV Ramnagar. So very good. So now some of the questions will be discussed later on. This is it from my side till now. If you have any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. And one thing more, Happy New Year. Okay. So enjoy the new year. Thank you so much.